conditions, n mod equal to n mod 2 is equals to 0, n mod 2 not equal, sorry, equal to 1. Okay, these are the two different conditions. Okay. And how many actions are there? 3 actions. Okay. We need to write the conditions like it is A and B, and actions, action 1, action 2, action 3. So we need to form the rules now. Okay, how to form these rules? So when this action 1 is going to be executed, in case of this A condition is true, then only we can execute the action 1, right? So here, in place of this, we are going to have Y. And what about B condition? If A happens, B must not happen. Right? If A happens, B must not happen. Because if n mod is equals to 0, it cannot be equal to 1. Nowhere it is possible. So nowhere it is possible. Sorry for the disturbance. I'm getting continuous calls. Okay. What's it now? Okay. If A is true, B must not happen. If B is true, A must not happen. Right? And one more thing is the action 1 is going to be executed when A is true. A receives this Y. Okay? If B receives Y, then action 2 is going to be executed. Okay? So when action 3 is going to be executed, if both are false, right? If both A and B got false, then no. Then that means action 3 is to be executed. The same thing we have drawn here. I think it's clumsy, otherwise just I will erase. I'm not getting eraser here, eraser option here. Okay. So if this condition A is true and if this condition B is true, then action 1. If this condition A is not true, if this condition is true, C is true, then action 2. If B fails, B is no, then this C is also no. Then we are going to execute action 3. Okay? I think I can remove this totally so that we can draw the figure again, no problem. So what is the condition here? The condition is A. What is this condition A indicates? N mod 2 is equals to 0. B indicates N mod 2 is equals to 1. Okay? If this condition is true, this condition if A is true, okay, then it means you observe this, simply you can get the idea. A is true. Okay, here I am talking about this one. Okay, no problem. Okay, we start with this. If A is true, then if A is the S path, A receives S path, then what I need to do? I need to go for this action 1. Action 1. So if A is not true, okay, let's write. Okay, I need to draw. Because here after checking this A only I am going to this B. A is not true. Then I am checking whether this B is true. If B is true, we need to go for action 2. If it is B, no, as well as A is also known, then we need to go for action 3. Okay, this is the way of representing the flow graph equivalent for a decision table. And somebody asked me, the representation of flow graph is somewhat difficult if you consider the program design language. There is no strict rule that you need to write the same program design language. You can write a small algorithm for any small problem. Okay, calculating the quartic roots of quartic equation, or calculating the factorial of a number, or like this, calculating, checking whether a number is prime or not. That means it should cover the loops concept, decision symbols concept. Don't get all the sequential statements. Okay, so that is enough. So if you know the algorithm writing, then you can easily write an algorithm and convert it into flow graph in a proper way. Okay. So I hope you understood how to draw the flow graph related to a particular program. I think yesterday I have shown you the flow graph related to the this A greater than B greater than C, right? Okay. That means which one is big value. So we talked about that. So are you clear? Are you clear with this concept, or shall we go to the big number among three numbers example? Decision table to prepare the decision table as well as the flow chart, flow graph. Whether you want that example, or shall we move on to the next concept? Please respond in chat. If you want that example, you say yes, otherwise why? Otherwise you say no. Yeah, no. Okay, Sushila. Okay. So it is very simple, right? It's easy to understand. Only one person responded out of 38 students. What is this? Okay. Okay. Okay, Jayasree Pujita. Okay. We'll go to the next concept. Okay. Because it's easy, right? Last class itself, I completed that. I hope all of you received the presentations. And I have used some more documents to explain the problems in probability computations and all. I didn't include it at that point. Okay, I will share the Word documents separately otherwise. Okay, next. So this is the point about preparing a decision table, preparing the respective flow chart. Okay. And the main point is here you can add a default condition in the decision table. But in case of flowchart, the problem is we can't create a separate line saying it as a default condition. So if you create one decision box, obviously it goes to what we call yes or no paths. We can't keep one more box for that. But you can create one box starting from first line like this. So with the decision box, you can't go for this. Suppose if you have a decision box like this and you are talking about this true false one. Default means it should be true for all cases, right? So here itself you can add this default case. FAU. Okay, it ends up. So this is the way to represent the default case in flow. Okay. So what about this I immaterial case? That particular value may take either true or false, yes or no. A simple example I would like to tell regarding this. Suppose if we are checking whether this A greater than B, A greater than C. That means checking the big number among this A, B, C. Okay, in this case, A greater than B, A greater than C. Initially, you are going to check this to right. If this is true, that means if this is that means A is big. Okay, suppose we need to check other condition, right? For B is big. So B greater than A and B greater than C. Okay. So this is condition A, this is condition B, condition C, condition D. What about the effect of condition A on B, C, D? Suppose here I am writing a decision table like this, A, B, C, D. Okay, here I am preparing a like action 1. Action 1 is true, means A is B. I would like to say that if this is true, A happens, B happens, then action 1 is going to be executed. What about C condition? What about C condition? B greater than A. If this happens, what about this condition? It must not happen, right? A greater than B and B greater than A. Both cannot be true. Because it is not a case of A is equals to B. Even that case, it is not true, right? So if A is greater than B, then definitely B is not greater than A. So it must not happen. C condition must not happen. So it takes N. What about this condition? B greater than C. A greater than B, A greater than C, and B, if these two are happening, and B greater than A is not happening, whether it is going to affect this B greater than C? No, right? Whatever may be the resultant of B greater than C, it doesn't matter with this case. A greater than B is true, B, A greater than C is also true, and B greater than A is not happening there. And what about D condition? It can be true or cannot be true. Doesn't matter. So it takes the value of I. I hope you understood now. Okay, even though you said that no, you don't require this example. The problem is here we have certain immaterial cases. For that purpose, we need to study how to understand this immaterial case. So if you consider this action 2, okay, suppose I'm talking about B greater than A, B greater than C. Okay, if these are true, then B is big. If this happens, so what about the condition C greater than A, C greater than B? B greater than A, B greater than C. So this B, if this B greater than C is true, then it must not happen. Okay, these two are two exclusive events, right? What we say exclusive only, right? Yes, exclusive events. So they don't occur together. So if this happens, it should not happen. What about this condition C greater than A? A, B, C, D, this is E, F, otherwise. If D happens, F must not happen. If C happens, D happens, C and D and F bar is happening, right? What about this C, comma, A? What about this? We don't know. It may or may not happen. Doesn't matter for us. Right? It doesn't matter. It is not going to change the result of this B greater than A, B greater than C anyhow. So this is immaterial. This E condition is immaterial. If you consider this case, okay, this is not immaterial when you consider this particular case. Okay, when you are solving this one, In that rule, this is not immaterial. C greater than A. Here A greater than C happening, right? So IE is not immaterial. It depends on that rule. Okay? Rule instance. What is the instance of these conditions? Okay, what are the truth values of these conditions? Okay? So at that particular instance, only it is taking I. Later it is not taking I, it is taking some other value. Sometimes it may take yes, sometimes it may take no. Okay? This part is already covered actually last in last class itself. I explained this point. You observe the action one, action two. I'm going in a slow pace. The reason is people continuously giving the feedback saying that logic testing is somewhat difficult to understand. That means they need one more revision. Okay, that's fine. So if there is a program like this, definitely we are going to have one graph like this, flow graph like this. And for this flow graph, how to write a decision table. It is very simple to understand. You observe the paths leading to the actions. So action one consists of two achievable paths. Action one is having two achievable paths, and action two is having three achievable paths. This one, this one, this one. Action three is having this one achievable path like this. So action three is having only one achievable path here. If we consider this action one path, so it is going to have two rules now because it consists of two parts. So in these two parts, observe the values, observe the truth values of this A, B, C, D. Okay, this is A and A, S. B is also yes. Next D is yes. What about C? C is not mentioned here. That means C can be either yes or no. It doesn't matter to achieve this action one. So yes, yes, I, yes. If you observe another path, A, yes, B bar, no. And next, there is no C as well as D. So there is no such a matter like what is the instance of C and D that leads to this action one. There is such a matter. We just simply consider those two values as I only. So yes, no, I. Let's come into the rule 3. Action 2. AS, BS, D bar no. What about C? C takes I value because it is immaterial. C is not in this path. So yes, yes, I no. That is third rule. Coming to the other part here. So here this 4, 3, all these are representing the number of decision nodes only. It is not something else. You can also keep numbers like this. Okay. Now come to the next part. A, no, B is not there, right? And it is achieving action 2. So no, I, C, S, D, I. So no, I, yes, I. Next come to this one. No, next B is absent, right? So B takes I. So no, I, no, yes. It's leading to action 2. Okay, this one, no, I, no, yes. Next come to the action 3. There is only one path. No, no, no. But what about B? B is absent. B is I. No, I, no, no. Here, just to maintain the clarity without any confusion, simply we denoted like some order. We followed that order A, B, C, D. Okay, if you follow some different order, then it's somewhat difficult to identify the missing missing decision box. That's it. That's it. You can also keep this one as A, this one as B, some other value, no problem. Okay. And wherever is a node, you need to represent that node here. So whenever 2 points are joining, they represent the node here. Observe that. Okay, whenever 2 points are joining at one point, they represent with one node. Okay. So we form these rules. Okay. In case of rule 1, what is action? Action 1. In case of rule 2, the action 1 is happening. So rule 3, rule 4, rule 5 belongs to this action 2. So action 2 takes S1. So in rule 6, action 3 takes S1. Okay. So this is the decision table with respect to this program. So I told you, right, in material case, meta case of no. Suppose if you expand this table, then this rule 1 is going to be rule 1.1. Okay, one time it takes yes value, B condition 2 takes yes value, and other time condition 2 takes no value. So yes, 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 no. Yes, no, yes, no. Next, yes, no, yes, no. Yes, no, no, no. This is the thing. So this is the expansion. Now we do expansion for our problem, for our result, what we got in the last slide. So we got yes, yes, is, right? Simply we need to substitute the respect values. That means here we don't divided this total table into R1.1, 1.2, but in R1 itself, we have written the two cases, two combinations. Here, a simple observation is if you have only one I, that means it's going to have two combinations, right? Y, 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 N, Y. Okay, Y, 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 N, Y. Suppose if you have two I's, that means we are going to have four combinations for that. Because these two I's are going to take Y, Y, N, Y, N, N, and Y, N. So that's fine. So you are going to have this sort of combinations. For all times, that condition A is going to take yes only, right? So for yes, condition B is going to take no only, right? For no. And what about this? This is Ny for one time, Nn for another time, Yn for other time, and Yn for other time. So like this. And similarly, rule 3 also, Yn, Yn. So that is a thing. Here in rule 4, we have two I's. So you are going to get four combinations. Simply, condition E always takes n value, so it is 4 n's. Next condition B takes I. So condition C is always yes. So first you fill these two values, then you can keep this combination yn, yn, yn. Rule 5 is going to take only one I. That means either yes or no. Simply substitute that value. You are going to get these two combinations. Similarly, for this also you need to find the same. So like this, you can prepare this decision table. And if you expand the decision table, you are going to have this final decision table. So how many rules are here? You can observe that. How many rules are there? So here we have two rules, 2 plus 4, 6, 6 plus 2, 8, again 8 plus 4, 12, 12 plus 2, 14, 14 plus 2, 18 rules we have. Okay, that means for this flow graph, we receive 18 rules. Okay. Actually, this problem, they gave one the wrong interpretation. That's why I'm just going to the solution now. So you can understand, right? I already explained that it is C bar something, there is some wrong interpretation is there. So rules can also be expressed like this. Whatever we have written that yes, no, like that. So they can be expressed like A bar, B bar. How many combinations we are going to have for three variables? 2 power 3, right? So you can write all those combinations and you can explain easily the condition 1 when it is going to happen, condition action 1 when it is going to happen. The same concept can be interpreted in this way also. Next, path expressions. That means how we are able to compute uh, the resultant of a logic circuit. In similar way, we can also compute the resultant of a flow graph. So how it is possible? Here, first I told you, right, whenever two points are joining at one single point, we need to create a node and number that node. Here, I think it's a partial graph because in this node we can see it's not partial. See, 1, 2, the node 3, 4, 5. All these are decision nodes, and again 6, 7, and this is 8, and this is 9, and this is 10, 11, 12. Okay. So in the total graph, you need to observe each node junction. Okay, we can say that junction. Okay, observe this. Okay, what is the resultant of this point? What we are going to achieve at that point? So this point is equal to A, okay, plus A bar, B bar, C bar. Is there any other in link to this particular node? No. Okay, so N6 is equal to, what is the expression for N6 node? Similarly, how you are solving this logic circuit, digital logic design circuits. In similar way, we are solving this. Okay, there is not much difference here. You can easily observe that. Here also we follow the same Boolean algebra, expression evaluation, right? You same maps like KV charts. Okay. So if you have any specific questions like in this logic testing, logic-based testing, you please send me the feedback. Okay, then we will discuss that one also. I'm unable to identify which point you are asking actually. Because I thought that it is very simple topic. That means it's very simple to represent this using Boolean algebra. And we are also familiar with this K-maps. So you can be thorough with this KV charts also. Okay, these are the two concepts that reside in this logic-based system. Okay. Maybe I explained, in detail. Maybe in last class I didn't explain the conversion, how to create a program, how to create a flowchart from the program. So in this class we studied that, right? How to prepare the condition tables. We studied that point. Okay. This is the third point. So in this case, if you observe this point, N6 is equals to A plus A bar, B bar, C bar. And next come to other node, other junction. Why I'm not taking these values of N2, N3, because N2 is the end node that we need to compute at the end. If you take this N2, you need to evaluate all these intermediate nodes, right? So this N2 can be considered later. Otherwise, you can also start with N2 expression, which is of this form. But to evaluate this, first of all, we need this N6, N8, N11, and 12. So once we come to all these things, then we can simply evaluate N2 also and expression also. N2 is the final component that we need, right? Final expression, it's the resultant expression. So N6 is this one. What about N8? What about N8? N8 is equals to this N6B. N6B. And in between there is no other value here. N6B. Okay. And next, what is that? N6B. And next, what is the other path for this 8? There is another path, right? This path. A bar B. So N6B, A bar B. So these are the two different paths for N8. So simply I have written those two values. So you can evaluate this one by substituting this N6 value. It's already in terms of ABC. Okay, if you evaluate, you are going to get some expression here. for this N8 also. That means we got the expression for N6, we also got the expression for N8. And what about N11? Next one. Where is N11? Yes, this one. So for this N11, there are two incoming links. Okay. So one incoming link is coming from this point, that is N6 B bar. Okay, N6 B bar C. N6 B bar C. Okay. So next other path is N6 B C. Okay. So this N6BC, there is one intermediate node. Already we know this N8, right? So we can also write this N8C. Or N6BC is also right. But we already completed this N8. We can take from this N8C. Okay. And next coming to the 12th one. So now we know this N6, N8. Then we can easily compute N11 also. Later we can see the computation. They're also written there. And coming to the point of N12. So that is N12 here, N2 is having two links, right? So this path and this path. This path, if you observe this path, A bar, B bar, and what about this? C. A bar, B bar, C, and one more path is from this. N6 only, it's not N8. N6 only, see. So one path is from okay, one path is from this only, right? Okay, this path. So N8C. There is some mistake here. Okay, we already computed this N11. Okay, no need to count the N8 and all. So N11 is enough, right? Because we already computed this N11. So simply we can write N11. But there is no link name here. Okay, simply we can write this. Maybe we can understand that it doesn't matter. That means it doesn't consider A, B bar, C bar, D bar, and so on. The reason is it maybe the don't care value. That's why there is no link name there. No specific link name is mentioned there. For remaining cases, something should be true to reach that particular point. But here, 11 to 12, there is no such a path. There is no such a condition. Simply we can straightly reach this 12, whatever may be the point. Okay. So N12 is N11 plus A bar, B bar, C. This is the thing we got. So already we complete this N11 using this N8, N6 steps. Then we can go for this N2. So N2 is the end expression. In upper part also we can observe this N2. In lower part also there is one N2. So if in the upper part, again there are two paths, right? This path and this path. So what is this path? This path is coming from this N6 B bar C bar, and this path is N8 C bar, N8 C bar. These are the two paths. This is N6, this is N6 B bar C bar, and this path is N8 C bar. And what about this particular path? This is okay, sorry, this is this part, right? 12 and 12. It's because we already completed this N12, you don't need to consider this previous links and all. Simply, this is N12. So this is direct link from N12 to 2. Okay. This is the equation framing. Then we go to the evaluation. That means we just started equation framing and it's very easy to compute. We already know this N6 already computed, N8. Substitute N6 to get this N8. And once N6 and N8 are known, simply we can substitute and get this N11. Once you got this N11, then you can get this N12. Once you got N12, simply substitute N12, N8, N6, you are going to get N2 expression. Why we are evaluating this N2 expression now? What is the requirement? I told you, right? Before preparing the circuit on the board, breadboard, first of all, you need to create the circuit on paper. Then identify the expression for that circuit, resultant expression for the circuit. And now you need to input the, because here we are not testing the disconnections and all. We are not testing how these circuits can be disconnected or something might happen so that it's not going to give the wrong, it's not going to give the right result. We're not talking about that. Actually, whether we have done whether the circuitry is correct or not, the logic is correct or not. To find a factor, suppose there is a question, find the Armstrong number. Suppose if I have written one logic with identifying what are the numbers here? Relation to Armstrong number, some other number. So the logic is not right, correct or not? So here we focus only on this logic is yielding the right result or not. So we don't bother about physically how they are connected. Okay. First, we try to prepare that circuit on the paper, and then we compute the final equation for that logic circuit. Then we substitute all the inputs, input combination ABC 001, 010, and so on, like that. And let us see whether the output is the value of that particular expected value or not. Similarly, here also we are doing the same. So these are the rules of Boolean algebra, which you are already familiar with this. And here in this case, AB is equal to BA. Then I mentioned here AB is equals to BA. Meaning NA, it's also multiplication. Here a statement can be such be AB. Both are true. So either A and B are true, B and A are true. It doesn't matter. It means like P and Q, Q and P, right? Okay. So this is the evaluation, expression evaluation for the previous flow graph. So N6 value is A plus B bar C, and again we complete this formula, right? N6B into A bar B, and later they substituted A plus B bar C bar in N6 place. Now multiplication AB plus B bar C bar B, okay, plus A bar B. This is A bar B, right? Yes, in next step it is correctly written. So there are certain editing mistakes. I hope you can easily identify them. So this is B only. Okay, A bar B, and the next step it is normal, right? So if you take AB this one and B bar. So what is this B bar B? B bar B. It is not happening, right? It means the total value is 0. The total value is 0. B occurs, B doesn't occurs. If you consider together, this value is 0. This AB and this is C, 0C, and this is A bar B, and the 0C is 0, and AB, this is A bar B, and this is AB, A bar B. So if you take this B as common, A plus A bar. So A plus A bar is 1. You need to revise the Boolean algebra expression once again. Okay. A plus A bar is 1. Okay. A bar is 0. So you are going to get 1B. That is B only. It's very simple. N8 value is this one, N8 value is this one. Now if you substitute these two values in N11, so what are the values of this N11? N8C. That means N8 is B, right? So BC plus A plus B bar C bar. A plus B bar C bar into B bar C. Okay. This BC, ABC plus B bar C bar, B bar C bar, B bar C. Again this CC bar. BC plus A B bar C plus. So the same expression can be evaluated for many number of times, many number of methods. Okay. So again, we can easily observe there is one CC bar. C bar, CC bar. If you such, that means here AB is equals to BA, right? Here AB is equals to BA. So I'm directly writing that this expression is going to be zero expression. We end up with this one only. Okay, we end up with this one only. And what about this BC plus AB bar C? Otherwise, we take this one as common. AB bar C, BC plus AB bar C, and here, if you take C as a common, B plus B bar A. And this leads to B plus A. These formulas are same even if you follow this MFCS or DLD, because these are Boolean algebra expression evaluation. B plus B bar A is equal to here there is some, yeah, B plus B bar A is equals to the same value A plus B. So similarly we got this A plus B here. So this is AC plus BC. So now we can compute N12. So like that you need to proceed computation of N12, then N2. Okay, finally you got the N2 value as 1. So it indicates that this logic is yielding certain result, whatever you are expecting. Mentioned some other results here and saying which was these three are wrong. So it's not taken into account, it's not required. So while solving these problems, you no need to mention this names of the formulas, but you mention in brackets in mention that why you got this, since this is the formula. Since this is the formula, you got this step. So in expression evaluation, you need to consider, you need to explain each and every formula. Okay. So in next class, I'm going to continue with the KV maps. Is it required to revise this KV charts or not? You just mention in chat box.